This is the video for Mod 7 Lesson 5, Trig Ratios on the Coordinate Plane, Part 2. For this video, this is actually just building on what we did in the last section. So using positive and negative properties of ratios to determine where an angle is on the coordinate plane and finding ratios using given information. So again, just building on what we've already been doing. So we already talked about in the last couple of videos, graphing angles on the coordinate plane. So we know that we have our initial side and we have 0 degrees, 90, 180, 270, and then it circles back around. We also saw what happens when we have a point on the coordinate plane on the terminal side, and we had some signs, and sine was positive or negative, or tangent was positive or negative, and so forth. And so we're going to use those relationships to do other problems. Just kind of a reminder, we saw in the last, like a table in the last video. So points are obviously in the form of x, y. Sine, we said, was y over r, where r was the hypotenuse. Cosine was x over r, where r was the hypotenuse. And tangent, we said, was y over x, right? Where r is always positive. So what happens then is, depending on what quadrant we're in, that's going to tell us if sine, cosine, or tangent is going to be positive or negative, and so forth. So quadrant 1, we already said, was between 0 and 90. And this is kind of basically to look like, this is like a giant coordinate plane here. There we go. So basically from 0 to 90, we're going to notice that all the points in quadrant 1 are positive. X is positive and y is positive. So what happens is when we do y, and then r is always positive. So when we do y over r, that's going to give us a positive number. When we do x over r, that's going to give us a positive number. And when we do y over x, that's going to give us a positive number. So what we see in quadrant 1 is that sine, cosine, and tangent are all positive. So your ratio will be positive in that. And then obviously the reciprocals kind of follow suit. So basically they're all positive in this quadrant. In quadrant 2, that's when we go from 90 to 180. And our coordinate points, the x is negative and the y is positive, right? So just how we plot points. So if we think about it, since sine is y over r, if y is positive, sine is going to be positive in quadrant 2. If cosine is x over r and x is negative, cosine is actually going to be negative in quadrant 2. And then tangent is y over x. And since they're different signs, positive over negative, tangent will be negative. So how it works out is in quadrant 2, so we would have that sine is positive, cosine is negative, tangent's negative. So basically, in this quadrant, sine is the only one that's positive, and in quadrant 2, they all end up being positive. Same thing for quadrant 3, so same concept. We're going 180 to 270. And if we think about for sine, sine is y over r. In this quadrant, x and y are both negative. So y over r would be a negative over a positive. So sine would be negative. Cosine is x over r. And x is negative, so cosine would be negative. And tangent would be y over x. So you'd have a negative over a negative, which would be a positive. So in quadrant 3, we actually get tangent to be the only one that's positive. So we would have sine negative, cosine, negative, tangent, positive. So the only one that would be positive in that one is tangent. And then finally the last one, that would be from 270 to 360. In quadrant 4, the x values are positive, the y values are negative. And if we follow that same pattern we've been using, so sine would be y over r. So sine would actually be negative in this quadrant. Cosine would actually be positive because it's x over r and x is positive. Tangent would be negative. And so the only one that would be positive in this one is cosine. I'll do this in the same color. So what we like to think about, there's a couple acronyms you can use to remember. So in quadrant 1, you got quadrant 2, quadrant 3, and quadrant 4. So one acronym that you can use is all students take calculus. So what that means is A is all of them are positive, S is only signs positive, T is only tangents positive, and quadrant 4 only cosines positive. Another acronym you can use, because some students don't like that one because not all kids actually take calculus. So another one you can use is all Slurpees taste cold, and it's the same thing. So all are positive in quadrant 1, sine is positive in quadrant 2, tangent's the only one that's positive in quadrant 3, and cosine's the only one that's positive in quadrant 4. So any of these will work to help you remember the different signs. In the first examples, all we're doing is simply stating what quadrant the angle lies in. So when we look at this, first I'm going to set up the same thing. I know quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And I'm going to write my little acronym. So all Slurpees taste cold, right? So in quadrant 1, they're all positive. In quadrant 2, sine's positive. In quadrant 3, tangent. And in quadrant 4, cosine. So in this one, it says sine is greater than 0. So anything that's greater than 0, that means sine is positive. And so if sine's positive, it can be either quadrant 1 or quadrant 2. Right, so either they're all positive or sine's positive. And then they tell us cosine is less than 0. So cosine, anything less than 0, that's saying it's a negative. So what that tells us is it can't be quadrant 1 because everything's positive in quadrant 1. So where's cosine negative? And that's going to be quadrant 2. So our answer for this one would be quadrant 2, because we know in this quadrant sine is positive, but cosine is negative. In example 2, same thing. So we have here a few things. We have tangent is greater than 0. So that's basically saying tangent is positive. We have cosecant is less than 0. So that's negative. And remember, cosecant is the reciprocal essentially of sine, right? So that's like saying sine is a negative. So really that reciprocal tells us the sign of the original function. So now when we look at our quadrants, I'm going to do the same thing. So all students take calculus, or all Slurpees taste cold. And I'm looking to where tangent is positive. So that could be either quadrant 3 or quadrant 1. But we have that sine is negative. So we know it can't be quadrant 1 because there's no negatives allowed in quadrant 1. So this would be an example. It's in quadrant 3. And that would be your final answer. And then finally, the last question is for cotangent. Cotangent less than 0 is negative. So cotangent is the reciprocal of tangent. So tangent would also be negative. And then cosine would be positive. So if we go ahead and look at that, we know it can't be quadrant 1 because they're different signs. And again, all Slurpees taste cold. We're looking for where cosine is positive, but tangent is negative. So this would be quadrant 4. For the second topic, we're using those angle restrictions now to get all the trig ratios. So this is kind of just putting together what we've already been doing. So a few things, they give us sine is 3/5. So right away we know cosecant is 5/3. And this is very similar to what we saw in the first section. The only thing is now we have negatives and positives. So we have to kind of figure out what quadrant everything's lying on. All right, so we know that in this case, they tell us cosine is negative, right? So we know that our sine is positive, but cosine is negative, so they're different signs, so we know it can't be in quadrant 1. And so it actually is going to be living in quadrant 2, because sine is positive. And so a few things we know here. So if sine is positive and it's in quadrant 2, that means cosine is negative and tangent is negative. So I'm actually going to put those little signs there. So I remember that the other ones are all going to be negative. I can then draw my little reference angle. And sine is 3/5. So if I remember SOHCAHTOA, my opposite side is going to be 3. My hypotenuse is 5. I have to find, I'm going to call that x for now because that's my x value. I have to use Pythagorean Theorem. And we're going to get 4. And then this is my adjacent, my opposite, my hypotenuse. And so my adjacent is going to be 4. But really remember it's a negative cosine. That's why putting those signs in the beginning is kind of nice. If you want to put a negative to remind you. So it's actually negative 4/5. And this will be 5/4. And then tangent would be 3/4, but it's actually a negative 3/4, right? And then this would be negative 4/3. And that would be your final answer. For this last example, that's actually a negative radical 5/3. Same thing. So I'm going to go ahead and first figure out what quadrant we're in. So I'm going to put all Slurpees taste cold. Cosine is negative. Negative 5 root 5/3. I already know secant would be the reciprocal. And I might rationalize at the very end. So I also have cotangent is positive, which also means that tangent is positive. So I see they're different signs, so it can't be quadrant 1. So it's actually going to be quadrant 3. So something like this. So I'm going to have this little reference angle that I'm going to use. And so when we label this out, we have SOHCAHTOA. And they tell us cosine is negative root 5/3. So that means my adjacent is root 5. And then my hypotenuse is 3. Actually, I labeled that. Let me fix that. So we have root 5 and then the hypotenuse is 3. If you want to put a little negative to remind yourself, you can, but again, we're going to kind of fix it up in a moment. So if it's in this quadrant, we know that tangent is positive. So these are both going to be positives. We also know in this quadrant, tangent's the only one that's positive. So we know sine's going to be negative. So if you want to put those signs in the beginning so we don't forget. And then we need to do Pythagorean theorem to get that other leg. So when we go ahead and do Pythagorean theorem, we're going to get y. We have y squared plus negative root 5 squared, or you could just do root 5 squared. We'll just treat it like a positive. Equals 3 squared. And we're going to get 2. And so now the sign is going to be 2 over 3. So it's actually negative 2/3. That's why it's kind of nice putting the sign there in advance. Cosecant, negative 3/2. And then tangent would be 2 over radical 5. Or radical 5 over 2. And then the last step would be to rationalize. So we have to rationalize tangent, which is positive, and secant, which is negative. So negative 3 root 5 over 5. And 2 root 5 over 5. And then this would be your final answer.
If you have questions from the notes, please make sure you're asking questions in class, during T-Bolt time, or in the center. You do need to complete the U-tries to receive full points for these video notes. So when these are checked in class, you do need to make sure you have your U-tries completed to receive full points. So again, the remaining problems from this section need to be completed, even if they're not perfect. We need to see that you're trying the steps out before you come to class so you're ready to ask questions. All right, thank you very much and have a great rest of the day.